Here is my nearly completed payout flashing circuit for my Nishijan Model B pachinko machine. Kind of happy with it. Still a couple things I need to iron out. Well, really just one thing, but overall, really happy with it. To accomplish what I wanted to for this, I needed to combine basically three different circuits. The first one, well, before I get into that, it uses two ICs. It uses a 556, which is just two 555, how many fives? 555 timers in a single package, and then it uses a 4017 decade counter, and then also a couple capacitors, some resistors. So not a whole lot to it. And before I go on, yes, I could have done all this with an Arduino and been done with it in like 2 minutes, but that seems kind of silly to me for its use, because an Arduino just seems like overkill to me. All I need to do is trigger sequentially flashing LEDs. So I decided to do it this way. It's a lot more fun to me, so that's what I did. So the three circuits. First you have half of the 556, which is timer A, because 555 is two, or the 556 is two 555 timers in one. God, there's too many fives in this. Timer A in the 556 is set up in a monostable mode. What that means is when it gets an input, right now I just have a momentary push button, but when it's finished it'll be in the machine and it'll use the little read switch thingy in there. But just a momentary input, it turns into a lengthened pulse. And the lengthened pulse can be adjusted. I haven't added a variable resistor in there yet. I've thought about it. I'm not sure I will. I probably will, but just to get it working, I didn't bother. So now that pulse is set to about like 3 seconds or something like that. So the timer A takes a short pulse, turns into a long pulse. It takes that long pulse and feeds it into the trigger pin for timer B, which is the other side of this 556. Now, timer B is set up in astable mode. What that means is that as long as it has an input on its trigger pin, it will output a pulse from its output pin. And the pulse width is adjusted with this variable resistor right here, so I can speed it up or slow it down. And that pulse, the blinking pulse basically, goes from timer B of the 556 to the clock pin on the 4017. What that does is it causes, every time the clock pin gets a pulse, it progresses one step in its counting. So the 4017 has 10 outputs, so I could have 10 LEDs here, but I only had 5 on hand, so that's what it has. So the pulse from timer B goes to the 4017 clock pin and triggers the lights to flash sequentially. You can use less than 10 like I did here. All I did was, so I have 5 here. I took the output for what would be the 6th LED and tied it right into the reset pin of the 4017. And that just resets the cycle. So, and you could do that on whatever output pin, or you can leave it be, and there'll just be a kind of blank moment between cycles, or whatever you want to do. So I guess I'll trigger it, press the button, and it does its thing. And this also shows the one of the things I still have to do is I need to make it reset when the cycle finishes. And the way I'll probably do that is just use an inverter, which is basically just a all-in-one package with a transistor, and it inverts a pulse. So I'll tie that into the switch, actually. So when the switch is low, the output of the inverter will be high, which is going to the reset on the 4017, and that'll reset it to its first step. And then what I would need to do if I don't want any LEDs on is leave the first step blank. So that's one way I've been thinking about doing it. Or I could tie in an inverter into the VCC of the 4017 and just cut power or something. I'll figure something out. I could even, anyway, there's a few ways I could go about doing that. But that's where it is. Really happy with it. Figured it out on my own, which I'm rather proud of. You can go slower, or we can go faster, and it works without using an Arduino. Just 2 ICs, 2 capacitors, and 1, 2, 3, 4 resistors, and 1 variable resistor. Not a whole lot. And although it looks like a rat's nest, it's just because I'm using these convenient pre-made jumpers. When I design the circuit board will be pretty simple too. So that's where I'm at until I figure out how to reset that 4017 after the thingy. So thanks for watching. Bye.